Premix, street versus race. So in most of my race cars, I'm generally running around 1 ounce to 1.5 ounces per gallon. It really depends. For me, it's never really varied between a race gas or an ethanol blend. It's all a matter of choosing the right premix for the right situation. If you know you're running some type of exotic gas or some type of high ethanol blend or a methanol, then you've got to choose a compatible premix. On a street car, generally I'm not recommending, if your metering pump is going, anything more than about 1/2 ounce per gallon. And you do have to be sensitive to a car with a catalytic converter. A lot of premixes that are sold specifically for rotaries generally don't recommend anything more than 1/2 ounce per gallon. And that's usually subsequent due to EGR systems or, catalytic smog systems. So, if you're premixing your rotary, understand what the benefits are. A good premix is going to extend the rotary's life. It's going to help lubricate internally. And generally, metering pumps don't produce enough volume to support extreme conditions. So you always have to ask yourself, am I going to do extreme things, or am I going to do put an extreme load on this car? If you are, then it might be good to add a little more premix, but generally I never recommend exceeding anything more than 1.5 ounces per gallon, and that's with the metering pump system removed. And if you're needing more than that, you might have some other type of issue, a compatibility issue with the fuel and the premix. Or if you're looking at internal wear on your motor, it might not even be a premix issue. It might be some type of other parts friction issue. So generally, my street car, RX-8, or what used to be my Turbo 2 convertible, 1/2 ounce per gallon on top of a stock metering pump system with a good quality oil in the car that's also a compatible oil with a rotary that does need to be used in the metering pump system. And then with race cars, whether it was Mazda tricks, whether it's been my customers, whether it's been my own drift cars, generally 1 full ounce per gallon at minimum, and then we're usually mixing it heavier consistently. I'd say 1.5 ounces per gallon with our E98 ethanol blend. So a very high octane ethanol, and we're still using average rotary premix rates. So on the 2020 American Ethanol Renewable Lubricants Mazda Trix RX-8, we're running a factory Mazda Speed internal dry sump system. We did have to make some modifications. I added or increased the shimming to increase overall oil pressure. We're running WPC treated race bearings and a treated shaft throughout the motor. We left the stock E-shaft jets because we wanted to control volume flow of the eccentric shaft at idle, and we wanted to be able to rely on pressure and volume to really cool the engine at high RPMs and high horsepower range. So the factory dry sump system gives you one of the lowest profiles almost any motor can have. Most piston motors or external rotary dry sump systems, you need some type of point to catch oil at the bottom and be able to scavenge it out. The factory Mazda Speed dry sump system, or anybody who's making an aftermarket version of that same system, the scavenge is actually internally inside the rotary motor, and we can run a completely flat bottom pan, so there's no hang down to our oil pan, allowing our 3-rotor to sit extremely low and very far back, which I think gives the rotary motor an inherent advantage, being that there isn't a lot of upper end weight, and that there really is a cylindrical or very round mass that can be positioned low. So factory dry sump system, fantastic, stable pressure. Use them if you can get them, they're expensive. but they definitely have some advantages over external dry sump systems or wet sump systems, in my opinion. And you know, your external dry sump system will work fine if that's what you're running, it just has to be plumbed properly. And your wet sump system will work fine as long as it's set up properly as well. But a wet sump system, you're definitely gonna have a motor that's going to sit higher in your chassis profile. And when we're talking about Formula Drift or upper level racing, even though the factory dry sump system is quite expensive, it provides quite a few advantages to packaging and solutions to consistent oiling for the G-loading and what we're trying to do with the Formula Drift. We've been running Formula Drift for, I think, 15 years now. So through the career of myself and my engine building and what I've done with Mazda tricks, we've seen quite a few motors blow up. And we've blown some motors up in the Formula Drift circuit ourselves, but very rarely has it ever been a repetitive issue. And every time it's happened, it's been something that we have learned and we've been able to add to what our information package is that we can give to our customers, or what we can use in our own motor builds. Or it's been something where we hit a technological head point or stuck point and had to kind of wait for innovation to catch up. And so one of the, I think the most interesting things that we found out was that rotaries really don't like hard cuts when it comes to ECU tuning. And I think this is kind of common knowledge, and I think other people have suffered from these issues, but I don't know if there's ever really been like anybody talking about it. I think a lot of the times when issues happen, it's hard to quantify it. And through our Formula Drift program and with our tuner Nelson Savario, Haltech engine management, Mazda tricks, we were really able to pinpoint some things and quantify that, yes, everything else was fully operational. We had plenty of fuel. There were no heat issues. There was nothing else that was inherently going on in this given situation. But with a hard cut, there is some type of reverberation, some type of kickback, and we've seen it in other ECUs as well, Motecs, AEMs, and for whatever reason, the rotary does not like the hard cut. It does something, and it can damage the apex seal or damage the motor internally. So ever since that kind of point where we truly realized no matter how cool a rotary on a hard cut sounds, that there is a point where it can cause damage or some type of rhythm or pattern that is happening that can cause randomized damage. We have always ran a soft cut, and now for years we've literally been able to hang a rotary on a rev limiter away. Almost no other team can hang a motor on a rev limiter if they need to and suffer no damage. And I think a point in case would be yesterday in Formula Drift. We had our round 7 battle at Irwindale. We went up against Ryan Turk, extremely formidable driver, Papadakis Racing, an extremely formidable team. And we had an incredible battle. I think I ran my car all the way as hard as I could in that given moment. Just, you know, hitting the rev limiter, banging the gears, shooting fireballs, really just utilizing the car to that 100%, 120% if you know you have it. And I know Ryan did too, and when we finished the round, I looked down at my temperatures, I looked at everything, and we were warm. We were on the kind of the excessive side of where I like to see it, and everything hung in there. We idled away just fine, drove back to the pits. Unfortunately, we did not get the win, but fortunately, we did not have to rebuild the motor. And for that other team, they had ran so hard that they actually were rebuilding their motor. So I think that's you know, something very interesting to state, that you know, as we develop in Formula Drift, part of our goal is to always develop our rotary engine packages for Kyle Mohan Racing, myself, my shop. Check it out, www.kylemohanracing.com. For Mazda tricks, you know, been my original supporter and where we've developed so many different engine packages. But at this point now, we've got 2 full seasons on this block. You know, excessive temperatures at times, 9,500 RPM plus at times, close to 10,000. And we've had no issues. The motor's extremely reliable, and you learn your lessons as you go. And that was just one of those weird lessons we learned, and that was just a good question that came through, which was, what have you learned, and have there been any failures that led to successes? And I think that was really one for us as tuners, as engine builders, quantifying something that seems, like it's a standard through the industry. Everybody loves a hard cut, but really quantifying the fact that yes, that can lead to engine damage in a rotary if it's used, I would say, overly proficiently or overly excessively. Because in the times that it did happen, it was in situations where I couldn't lift, and I was out of RPM, and I couldn't make the shift happen, and we came back to the line and we had a little bit of damage. And so, live and learn. It's kind of being an engine builder and a Formula Drift driver at the same time. We gotta progress. And at this point, that was maybe 6 or 7 years ago. So, but I think it was good fact, good story, and rotary tales. So we're going to talk about the Haltech ECU, my Elite 2500, my tuner, tuned by Nelson S. I think if you find him on the gram or social media, and the safeties we're using to protect my motor in competition, to gather data and to keep things reliable. And I will add in there that when it comes time to actually run our battles, most of the time we turn all the safeties off, because we really don't want, any. I'd rather go up in flames than not give it all in the moment. But part of being there at that point in time, being there at the end of the day, conquering every new track we go to, gaining horsepower during the season as we're going, and always trying to improve our setup, is learning as we go. And I think that if everybody on the street used the ECUs and the functionality that Haltech or whatever they're using gives them, which can a lot of the times just be using the channels that are available and the safeties that are available, then a lot of motors could be saved. And certain channels that we definitely look at, we definitely run during practice, we definitely want to monitor, would be first of all our wideband. Your stoichiometric curve, you have to know what you're burning and where you're at. If you go too lean, you're going to knock, you're going to blow up your motor. And now, going lean can be caused by a lot of different things. It can be lack of fuel pressure, lack of fuel pump volume, lack of available duty cycle in your injectors, air temperature fluctuation, requiring more fuel delivery. If you're running flex fuel, then your fuel choice. There's so many things that need to be monitored right there, that just starting with your air-fuel ratio can give you a ton of information, and that's being monitored constantly and data logged in our Haltech ECU. And one of the channels that we do run a safety to in practice, and has saved our motor when we've had things happen, like we blew a fuel rail off one time, we caught the car on fire one time. That was a different time, and it was an oil issue. We had a little bit of catch can spill out, and it melted the harness, which killed the injectors, which was causing a lack of fuel delivery. So any of those types of things that fuel slosh in the tank, not going to happen in a race car, but can happen in a street car, that could cause a lack of fuel delivery, can save your motor if you're running a channel that's logging and looking at your wideband. Air temperature, your intake air temps. I think it gets overlooked a lot, but if you're exceeding your air intake temperatures for any reason, and you start to load the motor heavily, add boost in there, it doesn't matter if you were safe on the dyno or you were safe on a different given day. You're driving through the desert, you're at a hot track day, you've got a heat soak issue that didn't happen at a different time. For whatever reason it might be, that day you're generating a higher intake air temperature than a different day. It needs to be monitored. I think, a general rule of thumb is, your air intake temps should be pretty low. We're looking for under 100 degrees Fahrenheit. And as things get excessive, we're definitely starting to add systems in to aid them as we pass 120 degrees. Anything that gets excessive up towards 200 and below that, above that, really depends on what you're running, can cause detonation. So if you're not monitoring that channel. And generally I'm not running a gauge. We do on the Formula Drift car, but not on a street car. It's just a channel that my tuner or, you know, Mazda Tricks or myself is monitoring. So if there is an issue, like when your electric fans turn on, they're blowing hot air onto your air intake, or your air intake is somehow sucking air in off the manifold at a certain point in time when you turn a certain direction, or at a certain track the airflow is coming through the front bumper and it's not cooling your intercooler the same way. You're sitting at stoplights, you're getting heat soaked. There's so many things that can cause variations that for a long time in a new build, in a race car or in a street car, it's just a wise thing to monitor. I think, you know, as you start to go, you learn that more and more things should be monitored. We're always monitoring our EGTs because that can tell you a lot. If the EGTs start to vary, we might not be running a safety on it, but we're definitely looking at it. So it's something that could be done on a high horsepower street car or different variations of street race cars. But if something starts to vary too much, if your rotors, whether it be a 2-rotor, 3-rotor, 4-rotor, 6-rotor, if they're starting to not sync up, something's starting to get excessively hot or excessively cold, then you need to figure out why that's going on, and it would definitely be a reason to cut the car down. Now, I think I talked about some of the more advanced stuff, but I would expect everybody to have safeties on, you know, oil temperature, coolant temperature, oil pressure, fuel pressure. If you're not monitoring those, then you're just a ticking time bomb. And you definitely need to have your fuel pressure coinciding with your boost pressure, or depending on how you've had it tuned, you definitely need to be monitoring what's going on within those channels, and you should know what the range of green is versus red. I'm going to cause a problem. I think people always ask how to keep a rotary reliable, and I talk about running ethanol, having a high octane. I talk about you know, having cool intake, you know, needing to have good stable fuel pressure. But I think there's more to it than even just that. It's a matter of injector sizing to horsepower or boost delivery. And over the years, it's been interesting how the industry has had to keep up with what drifting has been doing, or with what the tuning industry has been doing, which coincides with what motorsports, the OEM aftermarket is doing. And I think for years we had horsepower caps. It was difficult to get above certain levels of horsepower. When I first started, it was, man, a lot of horsepower. It was 300 or 400 horsepower. And then it was 5, 6, 7. And at every step as we've climbed this ladder to 1,000 horsepower reliable performance, we've hit different points. And one of the interesting was, as we got higher and higher in horsepower, we had to get more and more injector volume. And this could be done by driving more injectors or by adding bigger injectors. And it's been really nice because over the past couple years, companies like Haltech, Evolved Injection, and the utilization of ethanol have allowed us to get the volume we need with the atomization we need with the control we need of the ECU into kind of harmony or yin and yang, so we're able to control the volume of fuel we need at the time we need to generate the horsepower reliably. And you know, there was a time where we had a couple failures simply because we ran out of injector duty cycle. You know, we had an extreme situation occur, we had a little bit of extra boost, or we were pushing the limits during competition, or, you know, we ran out of simply the amount of injector drivers we had in an ECU at the time. And this is going back years, but you know, currently in 2020, it's just fantastic because our Haltech ECU, we're driving 2,600 cc injectors from Evolved Injection, E98 ethanol, making roughly 850 horsepower at the wheels at 30 pounds of boost, very reliably with no issues. And I think, you know, it's just one of those things. As Formula Drift has evolved, horsepower has been needed, and it's forced us as engine builders, as drivers, and the tuners out there and builders out there to come up with new solutions to problems. And I think that was one of the things that really led me to running ethanol. Was it was a solution for so many issues. Race gas was so expensive. It's, you know, somewhat toxic. It'll give you a race car hangover. hard to store, hard to travel, hard to source, and we were able to get everything in harmony with ethanol, and we found a clean burning, readily available, American made, high octane fuel that costs way less, that was way more reliable and way more stable. And that combined with the injectors, the Haltech computer, the motor builds, which got stronger and stronger with the KMR apex seals, KMR studding, which we all developed at Mazda Tricks. It's now just a really solid motor. So I think, you know, the next step is definitely going to be to push it harder, add more direct port nitrous, and probably add more boost, but we're having to watch our EGTs and our other temperatures as we control ourselves into a even more horsepower fueled Formula Drift future. We already talked about apex seals a little bit, and apex seal selection, and another topic in that area that comes up is what size apex seal or how many piece apex seal. And again, I think it's relative to the situation. As the horsepower goes up, generally 2-piece or 1-piece is definitely, I think, recommended throughout. And in some situations, I definitely know some racers that prefer the 3mm, but that's not a old school 3mm. That's a redeveloped modern 3mm. However, myself, we found reliability with the 2mm 2-piece developed by E&J for KMR, and very similar to the E&J seals themselves. And really the advantages I like of the 2mm 2-piece are that it's always giving you a good seal. That corner piece can move, so it's not a 1-piece that's relying on heat expansion to fill the gaps. It still has a traditional apex seal movement. It's still a steel seal, so it's semi-exotic, but it's not all the way to a carbon or a ceramic or something that has other things, strengths, and disadvantages. So I really like its robustness as a 2mm steel. And then I like the weight savings. I think that's something nobody really talks about. A 3mm steel is heavy. I turn more RPM, I think, than most people do with similar versions of what is out there. And we're exceeding the 9.5, 9.8 range on a regular basis, sustaining that RPM under heavy load. It's not a drag car where you're just rising up in RPM and shifting. Drifting forces the max RPM for a long period of time, so everything has to be able to live at max horsepower, max load, max performance. And for that reason, I like having a lighter weight apex seal, because you don't want apex seal float, which can cause detonation and is very similar to a valve float situation or something like that in a piston motor. You can also get chatter, which can add to increased apex seal wear and increased rotor housing wear. So for me, where I'm trying to turn high RPM at high boost, at high horsepower, we're looking for all advantages possible. So we're splitting the difference. We're running a steel race seal that is malleable, so it does not break under detonation. And we're choosing to run a 2-piece 2mm for the weight savings and good seal ability. So lubrication, street versus race. This year we're running renewable lubricants, 2050 bio-based racing oil. They make street versions, they make industrial oils. My street car, running 2050. And my race car, right now I'm running 2050. And I've been very happy with the stable viscosity, the bearing wear, and have seen no issues come from running a heavier viscosity oil. And I do realize that a lot of modern cars, and this is where I get into, you have to make your own decisions on what you're gonna do, call for a lighter weight oil. It does help with startup, it does help with emissions, it does help with fuel mileage. Those are things I'm not looking for in my performance cars, and I consider my street car a performance car. At this point, I've spent over 20 years rebuilding rotary motors with the help of Mazda Tricks, other shops, different racers, my own shop, KMR. So we've seen quite a few things come through, and one of the things we've seen that's definitely given benefits has been WPC treatment. They're a treatment process that can be done to the cast iron steel plates, the rotor housings, the bearings, the shaft, apex seals depending on the material. And just like many other treatments out there, they boast a lot of performance gains or longevity gains. But what I can say is with Mazda Tricks Racing or with my own race cars, I have seen gains. And what I've seen is that it extends the initial high quality of your build for a longer period. If you build a brand new race motor and you don't WPC treat it, it'll go a certain amount. If you do WPC treat it, it will go longer than that untreated amount will at peak performance. So for our race motor, I'm not only looking for longevity of peak performance, I'm looking for reliability, and I'm looking for safety. And another neat thing we found out about WPC is within the bearing treatment and shaft treatment, things that would have killed motors in the past, slightly higher RPM when drivers, not me, but other customers have missed shifts or had over revs. It gives the motor an opportunity to make it past one or two mistakes that otherwise may have taken out a rotary motor and therefore other components. We've also used it on transmissions, seen great success with being able to run higher horsepower for longer periods of time. And then also a very neat thing is as you're lapping a rotary motor, which is always such a controversial topic, I lap all my motors, my race motors. This motor that's been in here for 2 seasons, it's lapped, it's WPC treated, where it looks like OEM, it's no big deal. And that's what I'm gonna get at is we don't re-nitride. I think that's definitely an option out there, but the housing's already been nitrided, so we choose to WPC treat after lapping, and that's also prolonging that lifespan after you've resurfaced. So definitely some neat things in there we've learned through the years. Friction modifier, so you're reducing the friction of any metal to metal component or bearing to viscosity component, and you're actually hardening the surface. So in certain cases where material might be malleable or breaking, the WPC treatment does also add some strength to it. So definitely recommend it. You can get it done through KMR, you can get it done through Mazda Tricks. Hit me up if you want to talk about it. But yeah, WPC, treat the world. What am I going to change in 2021? What have I learned this year in 2020 with our Formula Drift program that I might want to change? I think that I really learned that our reliability is reliable. Now we've got almost 2 seasons on the same block. That's very reliable. We've done this in the past. We're starting to see a pattern of reliability in the blocks. So I think I feel confident that we can actually push boost levels a little higher now and nitrous levels a little higher. I'm not looking to get into the realm of some of these teams out here that are changing motors all the time at events. I still like being able to run a motor for a season. I think that's a great advertisement for Mazda Tricks and KMR customers. But I would like to find some new limits. And with our new Nitrous Express direct port system, I think we can actually kind of push that further, and that's going to give us increased jump and increased throttle response for those chase situations. And I would say that I actually learned that I think we finally did get the setup and power band functionally right. I think the last couple years we struggled, porting options, turbo sizing options, we kind of went up and down, and really grateful with Precision Turbo and Haltech and everybody working with us to kind of find the medium we needed. And I think that just some minor changes going into next year based on the data we're seeing. And I want to really keep the car similar. Our chassis setup with WiseFab, I think, finally got there. I hate to say it, but the first couple of years we just didn't have the chassis dialed in, and I think the past 2 events we've been able to prove that the chassis belongs in Formula Drift, that our motors are making the power. We've been able to run right with Turk, hang with Forsberg, and now we're just looking for a win. And I think just a couple small jumps as we move into next year, we're going to be moving forward. I can already feel it.